Okay, guys, so let's look at an example here, how we can find the relationship for graph data. So here we have a graph. It's a distance versus time graph. So this is a graph that you probably graphed in physical science when you were in the physics unit. So here we have an amount of time that was measured, and as time went on, we looked at an object and how far it moved. Okay, so that's how we got this. Some things to notice. You see we've got distance is our y variable. So that is the measured or responding variable. And then we have our time. And time being on our x-axis tells us that that was the variable that the scientists manipulated. So the first thing we're going to do once we get our graph drawn is we are going to want to find a slope. So when we find a slope, you're going to pick two plots that are located actually on the line. So it has to be on the line to be able to calculate it within the slope. You will notice that as we start moving along and getting data and graphing them, that you'll have plots that will lie above and below the line. So they may be part of your data, but they are not calculated in the actual best fit line. So this would be called a line of best fit, because it best fits the data plots, the scatter plot that we collected. Now, when dots don't fall along the line, that usually means that they have some type of error associated with them. And that's okay, because it's normal. Because we're human, we're not always perfect in collecting the data, and there's always some type of uncertainty in those numbers. So you're always going to have some type of error within the numbers you've collected. That could be from equipment, that could be human error, it could be parallax. Parallax is when you're reading a graduated cylinder and not everybody reads it straight on. Some people are a little bit above, some people are a little bit below when you're reading it, so it throws off the measurements. It's the same with a ruler. I could put a ruler down and not everybody's going to read the ruler at the exact same number. Okay, that's called parallax. But it is a source of error, and error always occurs in the lab. So a line of best fit is basically an average of all of those plots that you have plotted. So when you're looking for slope, you have to make sure that the plots that you're calculating your slope are actually located on the line. So the two plots that we're going to use, I'm going to put them in purple here, are these. So this is 18, 2. And this one here is going to be 1. Oops, not 18, 2. I read that 0.2 as 2, and it's not. This is going to be 18. Let's see, 15. So 2.5. So this is going to be 22.5. And this guy over here is going to be 1 and 5. Okay, so we get these plots. So we're going to find our slope. So slope is going to be the change in y over the change in x. Okay, and so we're going to take, I'm going to take here 22.5 minus 5 all over 18 minus 1. Okay, and we're going to calculate the slope here. So I'm going to place it in my calculator really quick. And I'm going to get 17.5 over 17. And I'm going to get my slope is 1.03. Okay, now units. Okay, even with the units, okay, or even with slope, when you're dealing in science, you can still come up with the units. So if you remember, slope is y divided by x. So you take the units in the y which is meters, divided by, because that's the math function we did, over the x unit, which is seconds. So I get meters per second. Now, you guys, if you remember, meters per second in physical science was a type of velocity. So basically what this graph showed us, it gave us the velocity, is what the slope is. So the slope for this was actually velocity. It's not something major you need to remember in this course, but being able to calculate slope and coming up with the correct units is what I want you to focus on.